So the mass spectrum, you will see the two axes. The vertical axis is the current reading. It will also be shown as percentage abundance for you, and the horizontal axis is mass to charge ratio. Now you'll notice that this particular spectrum has two peaks, one at 85, one at 87, and those two peaks are of different height. So what does that tell us? Well, the number of peaks will give us the number of isotopes that we are talking about. So on the spectrum that we had two peaks, therefore our element has two isotopes, 185, 187. The mass to charge of the peaks, of course, gives us the relative masses of ions, assuming that our charge is a +1, the Z is +1. So in this particular case, we know that the relative masses of our two isotopes are going to be 85 and 87. And finally, the relative heights of the peaks gives us the relative abundances of each isotope. So we can work out the fractional abundance of each isotope by measuring each peak height, and the fractional abundance will therefore be the peak height of one of the isotopes divided by the sum of the peak heights of the rest of them. Now, from the data on the mass spectrometer, in other words the mass to charge ratio and the peak heights, we can use an equation to determine relative atomic mass. So we take the sum of the relative masses of each isotope, the mass to charge ratio, and multiply each relative mass by the fractional abundance of each isotope. That's the peak height divided by the sum of all the peak heights. Relative molecular mass, if we're looking at a particular molecule, we can also determine relative molecular mass, because that will be the peak with the highest value mass to charge value. Now that is not the one with the highest abundance necessarily, it's the one that's furthest to the right. This could be complicated by the presence of isotopes. So for example, if you have something with chlorine, a molecule with chlorine in it, you will have two peaks with the highest mass to charge value, because you'll have the two isotopes of chlorine, chlorine-35 and chlorine-37 in your molecule, producing two peaks.